Here's another example involving Snell's law, or the law of refraction. And key in here is to always write the formula. So we have sine theta 1 over sine theta 2 equal to n2 over n1 equal to v1 over v2 equal to wavelength 1 over wavelength 2. This is very similar to the sine law. If you've worked with the sine law in math, you just find any two ratios and solve for whatever you're missing. I always like to draw myself a quick little diagram of what median's going from where. We have a ray of light from air striking the surface of a block of glass. So we've got in air, this is my air, then we're in glass. The glass has a refractive index of 1.5. So since you're going from air to glass, you should be bending towards the normal. And what we're going to do is determine the angle of refraction. So we have this angle of 67 degrees. That's the angle with air. What we want to do is figure out this unknown angle. And remember, the angle is always the angle to the normal. So we have the index of refractions for both. Air is 1.00. Glass is 1.50. So we're going to go sine 67 degrees over sine x equals the index of glass, which is 1.50, over the index of air, 1.00. This turns out to be 1.50 times the sine of x equal to sine 67 degrees. So sine x equals sine 67 degrees over 1.50. And if you take out your calculator, how you find that angle x, you will go second function. Make sure your calculator's in degree mode. So press your mode and change your calculator to degree mode, or if you're whatever type of calculator you're using, go to degree mode. Then punch in sine 67 degrees. Divide it by 1.5. You'll get a decimal answer, but that's the ratio of the angle. To find an angle, you'll always go second function sine of that ratio. And you should get 37.85. If we go to two significant digits, should be 38 degrees. It should be smaller because when you go from air to glass, the speed of the ray of light will slow down. That means it's going to bend towards the normal. Try to remember that chart. Commit that chart to memory and draw yourself a little scenario every time. Your answer should always make sense, because the only time I see students make a mistake in these is when they mix up their numbers. They put one where the other one's supposed to be, mix up the incident with the refracted, and they get their answers backwards. Otherwise, the math turns out to be pretty straightforward in these cases.